Guys, today we're going to be covering 10.2 volumes of pyramids, cones, and spheres. This is the last thing that we have for this week in terms of notes. Everything will be covered, and then from here just work on the assessments and the practice. So let's go ahead and get started. If we were to compare a pyramid and a rectangular prism with the same base and the same height, we would notice that the volume of the pyramid compared to the volume of the prism is 1/3. So, it takes the volume of 3 pyramids to fill the prism with the same base area and the same height. So if I wanted to find the volume of a pyramid or any figure that ends in a single point at the very top, the volume would be equal to 1/3 big B, which is our base, the area of our base at the bottom, times the height of our actual prism. Now, important to note that B is the area of the base, H is the height or the altitude. It's very important that we also know that our height is still, once again, perpendicular to our base. It intersects 90 degrees here. So that's very important. Now, I also added in another variable, L. You may recall L from surface area. L has nothing to do with the volume here. So slant height, L, and height, H, are not the same. And it's very important that we know that this L is not the height of the pyramid. The height must go from the very center point straight down and be 90 degrees to the base. So that's very important to know. If we get L mixed up with H, then you're going to have tons of issues with these ones. So just keep that in mind. So go ahead and practice these problems out one at a time, and I'll be going through them with you guys shortly. All right, so for number 1, volume is equal to 1/3 big B times H, where big B is the area of our base, and looking at number 1, our base is a rectangle. So I'd have volume is equal to 1/3 big B, which is 6 times 5, the area of that base, times the height of our pyramid, which in this case is 4. So that gives us volume is equal to 1/3 of 30 times 4. Well, 30 divided by 3, or 1/3 of 30, is just 10, times 4, which is equal to 40, and then again we're in units cubed. So again, our units must be cubed. And there's our work right here, same exact thing. Go ahead and try number 2 out next. I'll be working on it in just a moment. All right, with number 2, we notice that we have the slant height. So I'm going to go ahead and draw a right triangle here. My slant height is 13. I want to find H, height, and I'm wondering what this length will be down below. Well, if I look at this pyramid, I notice that this is a square base. Both sides are 10. And I know that my height goes from the very center straight down to the midpoint in a right pyramid like this, in a square base pyramid. So therefore this length should be half of 10, which is just 5. So then we can solve for H. 13 squared is equal to 5 squared plus H squared. That'll give me 169 is equal to 25 plus H squared. H squared is equal to, if I subtract 25 from both sides, we get 144. And then we can take the square root of both sides. Well, the square root of 144 is 12. So our height is equal to 12. From here, we can go ahead and find the volume. Volume is equal to 1/3 big B, which is just 10 times 10, it's a square base, times our height of 12. Well, 12 divided by 3, or 12 times 1/3, will give us 4, so I have volume is equal to 4, and then 10 times 10 is just 100. So our volume is equal to 400 units cubed. And once again, here's our work for finding the height, and again for finding the volume as 400 units cubed. Next, try number 3. But with number 3, be careful of your base here, your base area. It is no longer a rectangle or a square, it is now a triangle. So, for this one, we notice that we have an isosceles triangle here. Both side lengths are 5, so we have an isosceles triangle as our base. So if I want to find the height of this isosceles triangle, I go ahead and I draw my auxiliary line. And since it's isosceles, it intersects at the midpoint down here. Well, if the whole base is 6, well, that'd cut it into 3 and 3. So I will go ahead and I take this right triangle that I just made through the isosceles, and I bring it up right over here. Now this is a special right triangle for us. This is a 3, 4, 5 triangle. I see that my hypotenuse is 5. One of my legs is 3. I can use Pythagorean's theorem and solve for it if I want, but I already know this is a 3, 4, 5 triangle. So I can say that my height is 4. Now that I know that my height is 4, I can plug it into our formula. Volume is equal to 1/3 big B, which is the area of a triangle, 1/2. The base is 6 of our triangle. The height, as we just found out, is 4 times the height of our pyramid. Well, the height of our pyramid is 4. So going ahead and doing this math, we get 6 times 4 is 24, times 1/2 is 12. 12 divided by 3, well, that's just 4. And then 4 times 4 gives us 16 units cubed once again. So the process doesn't change whether it's a triangle base, a square base, a rectangle base. We just need to find the area of that base and then multiply it by its height. And then, of course, since it meets at a single point at the very top, as all of these do, we divide it by 3. All right, and then go ahead and try number 4 for our last one here. All right, with number 4, we notice that the base area is 70 feet. So that they're already telling us, hey, big B is equal to 70 feet squared. So I plug that into my volume formula. Volume is equal to 1/3, because it's a pyramid. It meets at a single point at the top. 1/3 big B, which is 70 feet squared, times our height, which is 10 feet. Now, from here, we can go ahead and do this math. We get 700 over 3 feet cubed when we multiply all that out. And if I were to round it, it'd be 233.3 feet cubed. Now, again, the homework will tell you whether to round it or not. You're not going to leave your answers as fractions, so just be wary that you're going to be writing these as decimals, or you're going to be writing them as whole numbers. You're not going to be writing them as fractions. So our volume of this pyramid here for number 4 is 233.3 feet cubed. Hopefully those weren't too difficult. Again, remember this formula at the top here. Volume is equal to 1/3 big B times H, and you'll be set with pyramids, cones, and anything that meets at a single point. All right, next, volume of cones. Again, this doesn't change anything for us. A cone is a pyramid with a circular base. So the formula for the volume of a cone is the same as the volume of a pyramid, except we use circle terms. Meaning, instead of finding the area of a square, of a pentagon, of a triangle, anything like that, it's the area of a circle now. So we're going to now use pi r squared instead of big B. So the volume of a cone is equal to 1/3 pi r squared times the height of our cone, h. Go ahead and try out this first example down here below. Give it a shot. Pause the video if you need to. I'll be going through it in just a second. All right, find the volume of the cone with a radius of 3 centimeters and a height of 5. So I know r is equal to 3, because the radius is 3, and my height is equal to 5, so h is 5. So I plug those into our volume formula. Volume is equal to 1/3 pi times our radius squared, which is 3 squared, times our height, 5. Volume is equal to 1/3 pi times 9 times 5. Now I'm going to go ahead and do 9 times a third right now to make it so that we're dealing with smaller numbers. It becomes a little bit easier. 9 divided by 3 gives me 3 pi times 5, which gives us our answer as 15 pi. So 15 pi units cubed is the volume of this cone right over here. And again, the homework will tell you whether to leave your answer in terms of pi, or if you need to round to the nearest decimal place, which of course then I'd multiply by pi. But this is our exact answer, 15 pi units cubed. Hopefully that wasn't too difficult. Let's go ahead and try another. So, pause the video if you need to. Find the volume of the objects below. We have a cone here, and we have a composite figure. The composite figure is just like the last lesson. But let's go ahead and get started on this cone first. If I look at it, I see that we have a slant height of 41, and we have a normal height, h, of 40. What we're missing, though, is our radius, r. So with this, we can go ahead and use Pythagorean's theorem to solve for r. So I go ahead and I move this right triangle here. I just move that right to the outside, and then I can use Pythagorean's theorem to solve for r. So I now have 40 squared plus r squared, the two legs of our right triangle, is equal to our hypotenuse squared, 41. Well, if we do the math, 40 squared will give us 1,600, plus r squared is equal to 1,681. Subtracting 6,000 from both sides, 1,600 from both sides, we end up with r squared equals 81. And then to get rid of the square, we take the square root, giving us r equals 9. So our radius is 9. From here, we can plug that into our volume formula. Volume is equal to 1/3 pi r squared times height. If we do that, we end up with volume is equal to 1/3 pi times 9 squared times 40. Well, 9 squared gives me 81. I'm following PEMDAS here. 81 divided by 3 gives me 27. And then 27 times 40 gives me 1,080 pi units cubed. Again, you can enter this whole thing on your calculator except the pi, and it'll give you this number out front. And then you just attach the pi at the end here. So this is the volume of this cone over here. Next, our composite figure. Again, the rules haven't changed with volume and composite figures. To find the volume of a composite figure, just find the volume of both shapes, both figures in there, and then from there, you just add them together. So, if we look at this one, we notice that we have a diameter at the very top here. So our diameter is equal to 6. And since it doesn't look like our diameter changes, our diameter down below is also 6. So if our diameter is 6, that means our radius must be half of that, or 3. Now, I also can see here at the very bottom that we actually don't have a height for our cone. So we need to find the height of our cone. And we'll do that in just a second. Let's go ahead and start with the volume of our cylinder. So for our cylinder, we have volume is equal to pi r squared times height. Well, that gives us pi times our radius, which is 3 squared, times our height in this case is 50 on the cylinder. This would give me 9 pi times 50, which is equal to 450 pi. Let's just go ahead and leave it like that for now. Next, we go ahead and we look at our cone. Let me go ahead and draw my right triangle now. I know that the slant height of my cone is 5. I know that my radius is 3. I just need to find the height of it. Well, looking at this, we have once again a special right triangle, a 3, 4, 5 triangle, and you can use Pythagorean's theorem if you like. But again, just knowing that a special right triangle such as a 3, 4, 5 triangle exists, we can automatically say that our height is equal to 4. So height is equal to 4 here. And then we can go ahead and use our formula. Volume of a cone is equal to 1/3 pi r squared times height. This will give us 1/3 pi times our radius. It hasn't changed. It's still 3 times our height of the cone, which is 4. This will give us 1/3 pi times 9 times 4. Well, a third of 9 is just 3 pi times 4, which is equal to 12 pi. From here, for our total volume, we just add these together. 450 pi plus 12 pi will give us 462 pi units cubed. And again, here's all the work. Pause the video if you're having trouble going through this one, but here's the cylinder, here's the cone. We're adding them together because it's a composite figure. I'm not taking any volume out of it. I'm adding this volume on top of this volume. All right. Next up, spheres. This is the last thing that we have for the day. We're going to talk about spheres and hemispheres. The volume of a sphere formula is 4/3 pi r cubed. That's very important here. This is something that people often miss. They still use squared, In this case, it's cubed for volume. So, main thing, the radius will not change no matter where we are in the circle. It's the same radius from there to there as it is from there to there. The main thing, though, is that if they ask for height, well, the height is just the diameter. Or it's from the center, if it's a hemisphere, it's from the center to the top. So it'd be the radius as well in a hemisphere. So they may ask for height, they may ask for radius. Just keep that in mind. Most often, though, they'll be asking for radius, to be honest. So, find the volume of a sphere with a radius of 3 meters. Well, we know volume is equal to 4/3 pi times 3 cubed. Well, 3 cubed is 3 times 3 times 3, which will give me 27 times 4/3 pi. Well, if I were to multiply 27 by 4 and then divide it by 3, I'd end up with 36 pi. So, 4 times 9, hold on here, this is wrong, this should be 27 here. So 27 times 4 will give me, let's go ahead and do that math real quick. 27 times 4, that'll give me 28, 108, and then divide that by 3, and we get 3, 9, that'll give me 118, 36. So our answer should be 36 pi meters cubed here. So that's a mistake on my part. Our answer should be 36 pi meters cubed for the radius of 3 meters. Next, if a sphere has a volume of 288 pi feet cubed, what is its radius? Well, this time I'm going to go ahead and I'm going to take that volume, I'm just going to plug it in for V. So I have 288 pi feet cubed is equal to 4/3 pi r cubed. Now from here, if I want to get rid of this fraction, whoops, sorry about that, I go ahead and I multiply both sides by the reciprocal. So the reciprocal of 4/3 is 3/4. The 3 and the 3 cancel out, the 4 and the 4 cancel out. What I do to one side of my equation, I must do to the other. So 288 pi feet cubed divided by, or multiplied by 3/4 will give me 216 pi feet cubed. From here, on the right side, I divide both sides by pi, and I'll just get rid of that pi for us. So pi is now gone. We're left with 216 is equal to r cubed. Now, to get rid of a cube, I take the cube root. You guys may recall that before spring break. We take the cube root of both sides. The cube root of 216 will give us 6 feet. So our radius of a sphere that has a volume of 288 pi feet cubed is 6 feet. That's where it comes from. All right. Hopefully that wasn't too difficult. Just don't forget this formula. And don't forget how to find the cube root. It should be, if you have a TI-84, it should be in the math section. So if you click the math button, you should see a cube root somewhere in there. And that is what you'll press to get the cube root, to get rid of this exponent. So just keep that in mind. All right, our final problem of the day. A hemispherical dome has a height of 30 meters. So we just talked about this with the height. Our height is 30 meters. So if we look at this, in this case, we have a radius here, and our radius is the same exact thing as the height. So our height is equal to our radius. And that means that our radius is equal to 30. So find the total volume enclosed. Well, first let's talk about the volume of a hemisphere. The volume of a sphere is 4/3 pi r cubed. The volume of a hemisphere is half of that. So I take half of 4/3 pi r cubed. Well, let's go ahead and multiply these to find out what fraction we're actually multiplying by. So this will give me 1 times 4 on top over 2 times 3 on bottom. All I'm doing is I'm multiplying straight across to find out this new fraction, times pi r cubed, of course. This will give me 1 times 4 is 4, 2 times 3 is 6, pi r cubed, and then we go ahead and we simplify. Volume is equal to 2/3 pi r cubed. This is the volume of a hemisphere. So that's all we got to do to find out this total volume enclosed. Volume is equal to 2/3 pi times 30 cubed. Now again, this is 30 times 30 times 30 times 2 divided by 3. That's what we're going to be doing. Doing so will give us our volume as 18,000 pi meters cubed. So that's the volume of this hemisphere. Find the area of ground covered by the dome. So if I look at this, we have this dome here. The area of the ground covered by the dome, well, that's just the base here. That's the base of our hemisphere. So it's the area of this circle. Well, the area of a circle is just area is equal to pi r squared. And we know our radius is 30. So go ahead and we plug that 30 in. Whoops. And we end up with 900 pi meters cubed. Letter C, how much more paint is needed to paint the dome, the outside here, than to paint the floor? So what they're actually asking me to do here is they want me to find the surface area of the dome. And they want me to compare that to the flooring here, which would be that lateral area of the dome. So the surface area of the dome, well, if I recall the surface area of a sphere, it's 4 pi r squared. I'm taking half of that, and I'm not going to count the base towards it, because I just want to know the surface area of just the part that's showing that's not on the ground. So I'm excluding the shaded area here. So this gives me 4 pi r squared divided by 2, which is the same as 2 pi r squared. Well, our radius has not yet changed, so we have 2 pi times 30 squared, which will give us 1,800 pi. Now, we want to know how much more paint is needed to paint the dome than to paint the floor. So I take the surface area of the dome, 1,800 pi, and I subtract 900 pi, the surface area of the floor here. And that gives us 900 pi is the difference. So 900 pi more paint is needed to paint the dome than to paint the floor. Lastly, this is the difficult question. Find the radius of a dome that would cover double the ground area. So, we're dealing with area here. That's very important, and that's why I underlined it twice. So it's very important that we keep that in mind. The ground area is 900 pi meters squared. This is area, so it should be squared up here. And if that's the case, I can go ahead and I can plug that in, and we want to double that area. So 2 times the area, which would give me 1,800 pi. Now we want to find the radius, and we're dealing with area once again, so I'm just going to use the area formula, pi r squared. So we have 1,800 pi is equal to pi r squared. Dividing both sides by pi, we get 1,800 is equal to r squared. Taking the square root of both sides, well, if I take the square root of 1,800, I can break that down into 18 times 100. And I can break down 18 to 9 times 2. 100 is a perfect square, so I can take out a 9, I can take out 100. So give me 3 times 10, which is 30. Rad 2 is left on the inside. So our radius is 30 rad 2 for a dome that would cover double the ground area. And that's how we do this problem. This is probably one of the most difficult problems that you'll see, but this is it. All right, so homework is still available through Schoology for you guys. Go ahead and work on that throughout the week and make sure that you get that assessment done. If you don't finish that weekly assessment in Schoology, that's what we're grading for your guys' grades right now, so make sure that you guys are doing that to the best of your ability. You get 2 chances on it. Score above a 70%, and you automatically get 2 points added onto your score. Score less than 70%, you get 1 point added on. If you don't even try it at all, you get 0 points. I do not reopen these for you guys, so keep that in mind, because it's going to be continuously going every week. You could get 2 points added onto your final grade. If you don't do it, that's too bad. I understand that some things are going on in your guys' lives right now, but try and get these done. If you can't, just contact me, let me know. But there are lots of opportunities for you guys to try and bolster those grades while you can. And of course, I want to make sure that you can do that. Send emails to me. Come to office hours if you guys can. And please stay safe during this time. I hope you guys are all well, and I hope to see you soon. If you have any questions for me, please let me know. Other than that, I'll talk to you guys soon. Take care.